Okay. All right. Hopefully everyone can hear me okay. All right, so hi everyone. Thanks for joining the Using the API session. I'm Emily Harris, Senior Demographer at the Kempsey Gardner Policy Institute at the University of Utah. I will be moderating this session. So our presenters today in order are Anna Vasilitsa. She's an Emerging Technology Fellow at the Census Bureau. Then we have Fabio Correa, Research Engineer at the Claude Pepper Center at Florida State. Ben Taft, the Data Impact Manager at Higher Expectations for Racine County. And Jan Vink, a Senior Extension Associate at Cornell University's Program on Applied Demographics. Each presenter will have 15 minutes, which leaves 10 minutes at the end for our Q&A. So presenters, let's please try to keep to time. Before Anna starts, I just want to remind you all that one, closed captioning is available. If you would like to submit a question, please use the Q&A tab, not the chat. Feel free to submit questions during presentations, and then we'll get to them after all the presenters have finished. Recordings and presentation materials will be shared after the conference. So we're going to start with Anna, and her presentation is Streamlining ACS Data, the Case for Tidy Data. So Anna, if you want to go ahead and share your screen, and I'll start time once you start presenting.
Thank you, Emily. And just to make sure everybody can see my screen, if somebody can say yes, they can.
Yes.
Perfect, thank you. So today I'm presenting on streamlining ACS data, the case for tidy data. And the idea about tidy data comes from a paper by Hadley Wickham from 2014. You can see the URL there if you're interested in learning more about it. Highly recommend folks check out that paper. In terms of introductions, as Emily said, I'm an Emerging Technology Fellow at XD, and XD is an emerging technologies group that's advancing the delivery of data-driven services through new and transformative technologies, and we're a group within the Census Bureau. In terms of my background, I have a background in data science and public policy evaluation. So as you're hearing this presentation, keep in mind the emerging technology part of my fellowship and also my data science background. So first, before I get to how tidy data applies to AC or can apply to ACS data, I'll first define tidy data. I'll talk a little bit about what messy data is. I won't have enough time to really go into it, but if you're really interested about that, definitely check out the paper. I'll show an example of census data and its format, and also talk a little bit about open source packages. And then I'll go through a conclusion section as well. So my premise for this presentation is that there are advantages in adopting the tidy data standard for public data. And this is my wish, my hope, that this becomes true, that ACS adopts this standard, both in data.census.gov and Census API. So I love this visualization. It's from effective data storytelling. And so what this kind of shows is where users have challenges using data and data visualization, data analysis, communication, or actually taking action of data. A lot of those challenges actually come from data preparation. And so this is one of my motivations for giving this presentation and introducing this idea to all the users here. So one thing I will say is tidy data is independent of programming language and or tools. And the reason why I say that is because if folks know Hadley Wickham, he's very big in the R community, but tidy data is not R specific. Data that's formatted in a tidy way can be used by Excel, by Python, by R, by Stata, by SAS, etc. So what is tidy data? So one definition in the paper is it's a standard way of mapping the meaning of a data set to its structure. And I'll talk about what that means. So there are three principles or three characteristics of tidy data. It seems relatively simple as a concept, but then when you actually go into trying to create tidy data, it may not always be as simple as it seems. So the three characteristics is that a variable contains all the values that measure the same underlying attribute. So this could be age, this could be population. An observation contains all the values measured on the same unit. So for example, characteristics about a person, about a day, about a household, about a state, so on and so forth. And then each value belongs to a variable and an observation, and both of those are structured in a table. So to say the same thing, just visually, so our variables are our columns, our observations are our rows, and then the intersection of both are the values. And then this is where it gets maybe a little bit more complex, is tidy data can be wide or long. So wide or long isn't specific to tidy data, it's just a data concept. So the table you see on your left, it's known as wide data. So a wide data table is tidy if X and Y represent the length, for example, of the left and right arms. And the unit of observation in this case is ID. Another representation that's also tidy could be long data. And so the table that you see here is tidy if X and Y represent measurements of day 1 and day 10 of something, respectively. And then the unit of observation here is ID plus the variable. And so most often where we see long data is, for example, in time series. That's a very common way of representing time series data. Data tidying, that concept is structuring data sets to facilitate analysis and or machine learning modeling. So to summarize, the three characteristics of tidy data are each variable forms a column, each observation forms a row, and each type of observational unit forms a table. And so if folks know about database schema design, tidy data is pretty parallel to the third normal form. And in the paper, Hadley defines messy data as any other arrangement of the data. And I'll give one example. There are a couple more in the paper. I just won't have time to get into it. So in the paper, it uses an example of a table from a Pew Research paper. And what we see here is religion across our rows, and then income buckets across our columns. And the caveat that I'll make about this table is, in that report, this table was a visualization. And as a visualization, it works well. It's presenting the data that it intends to. However, if the intention of this table was for analysis or for visualization, it gets a little bit trickier to work in this type of format. And so how you make this particular example of a messy table tidy is you convert it into a long format. So every single religion gets every single income category, which is what you see on the right. And that's how you transform from a messy data set into a tidy data set in this case. And as a data scientist, it's much easier to visualize the table on the right than the one on the left. And now I'll talk about through one particular example of transforming ACS data from its current format into what a tidy format could look like. And all the data in the section is publicly available either on datacensus.gov or on the Census API. So I took a look at the public ACS one-year table B01001, sex by age from 2022. And this particular table was downloaded from data.census.gov. And one of the things we see stands out to me first is that we have the geography identifier in the column name. And I'll explain why that's important in a second. And then another challenge of this particular data format and how it shows up is the indentation can be challenging to work with programmatically. For a human user, we understand that the indentation means that those H categories belong to the category of the row above. Programmatically, that's challenging to work with. And then one thing, and this relates to specifically large language models or new users if they haven't used this data before, is if you just sum up all of the values in this table, you're actually triple counting the counts of the populations. And the reason why this is important specifically for large language models is if you ask what is the total male population in 2022, it doesn't, or if you ask the total population, it doesn't know to go to the total row and just pull out the 333 some million that's in there. What it will do instead, because the LLM seems to have a mental model of sorts, or an idea that, like, if you wanted to get the total of something, you have to sum up the whole column. So it's a challenging thing for LLMs to deal with, or at least has been historically. Maybe one model has solved that issue. And so I took that original table and I applied the tidy principles to it. And this is what I came up with, and this is how I would restructure the table. So as I mentioned earlier, the geography column or identifier was in the column name, so I made it explicit. It has its own column. And then sex has its own column. So you see here the male and the female. The age category has its own column. And then the estimates. I didn't include the margin of error in here just for visualization purposes, but if you wanted to add that in there, you could as well. I think the most important thing of this presentation and of the point I'm trying to make here is the underlying data hasn't changed. So for example, if you can see my cursor, the male under 5 is just over 9 million. And then we see that same value here. The one other difference to note here in the tidy data is we don't have the total population and we don't have the male and female population. If you want to get those numbers, you would have to sum up for the total population, sum up all the values in the table, or if you wanted to get the male population, you'd have to filter down just to the male categories and sum that up. I think that's the biggest change of what a tidy data set could look like for ACS. Also, I knew that the tidy census package developed by Kyle Walker also existed. So I was very curious, since it had tidy in the name, I made the assumption that it would structure the data in a tidy way. So I was curious what that package would return. And also I looked at a Python version of it as well to see how that data was returned. So the same table, B001, B01001 is returned in the long format, and they are very much similarities. So there's a geographic identifier, then the name for that geographic identifier. Then we have the variable, we have the estimate, and then I included the margin of error here. After joining the variable labels, we see that essentially the tidy format is what I kind of came up with, except all of the totals were also returned here to stay true to the original census data. Then the same table B001 is returned with census disk package. Again, this is an open source Python package that pulls from the census API. And then this data set returns the exact same data. This particular estimate, that's the total population from that table. Again, 333 some million people. But it's returned in the wide format. And I think this is an interesting format to return things in. From my understanding, this is what the Census API returns things in, or something very similar to it. But as a data scientist, this is particularly for analysis and visualization and also merging data can be really challenging to work with because you don't have the context of what do these estimate identifiers actually mean.
Anna, you've got 2 minutes left.
Okay, I'll go through this really quickly then, thank you. So what could tidy data enable for the ACS? And one of the things that I want to mention here, I know this is the ACS user conference. One of the things I want to emphasize is with new and emerging technology, particularly with Gen AI and LLMs, there's a new user that we should consider, and that user is machines. And structuring this data in this way will make it easier for people and for machines. We can tidy data will enable filtering, sorting, reducing data transformation time and duplication of efforts for data users. And I'll just say this really quickly. The screenshot that I'm showing here is the Google Data Commons. This is their transformation specification. It has 2,382 lines to transform a single table, a single ACS table, S0701. That's a lot of lines of code for transforming one table. It will enable easier data joins because now this table has 3 variables that you can join on. It will reduce transformation burdens for visualization, for mapping. And it will, I make the argument that Tidy Data Standard will make census data and ACS data easier to use for a variety of users. And with that, I'll say thank you very much. This is my contact information. If you have positive feedback, if you have strong feelings about this, please reach out to me. I would love to hear your feedback. If you're curious about what XD does, please check out our website, www.xd.gov. If you think you want to partner with XD, please reach out to inquiries@xd.gov. And thank you so much.
Thank you, Anna. That was great. Make sure you check out the chat because lots of people are having fun in there about your presentation. Okay, so next we're going to have Fabio Correa with spec files as tools to maintain and extend ACS API queries. You can go ahead and I will give you a 5-minute warning, Fabio, okay? Oh, you're muted, Fabio.
Okay, can you hear me now?
Yes.
Yes.
Okay, thank you. Good morning and good afternoon, everyone. My name is Fabio Correa. I am part of FSU Claude Pepper Center, and I'm going to be sharing about spec files and about how we can use them as tools to maintain and extend our ACS API queries. First, a little bit about myself and the platform. I am the developer of the translational data platform here at FSU Claude Pepper Center. The platform offers interactive products that combine United States Census Bureau data with other national data sets. And the focus of our products is insights on age and aging and healthcare and public policy. Usually our products take the form of web pages on our website, also analytical studies that we carry out for our partners or for our clients, also for our own peer-reviewed publications. Our steering committee is a multidisciplinary team of collaborators who discuss all scientific and policy aspects of our products, and I am in charge of the technical aspects, including procuring the data, processing it, and putting it into our web pages. Our platform procures data from the U.S. Census Bureau and other national sources, and here is a simplified diagram of how we use the data from the point of view of the metadata. At the top, we have some of the national data sets that we use. We use, for example, the American Community Survey list of estimates. We use variables from the County Business Patterns, the program. We also use variables in the U.S. decennial census. And below we have just very simple examples of the kinds of products that we build. And we put different data sets different variables in each of these products. In this example, we use the ACS and the CVP in the first product. In product 2, we use the 3 national data sets that I am putting in this example. Product 3 is only based on American Community Survey, and so is product 4. And for each of those products, we build a separate spec file. So what I'm going to do is to explain how these spec files work. We frequently, in our platform, we frequently produce new versions of our products based on newer data sets, for example, new versions of the ACS, and also, well, new versions of our own products based on new features and functionality. So for this presentation, what I would like to do is to promote in every one of you communication, efficient communication in your own teams. In all of this in terms of being able to communicate with your teams about the surveys that are being used in your products or in your research, the variables that are being used, the universes that correspond to each of those variables. Also, I would like to promote accurate labeling, accurate grouping. In the particular case of our platform, we have to, it is a common day task to put age groups into our products, to put race groups into our products, or to, for example, classify people regarding to income. So we want to be able to produce accurate labeling and accurate grouping according to these criteria. We also want to be able to produce accurate upgrades of our products. For example, a very common task that we find ourselves doing is adding variables to one of our products, or changing the labels, changing the names of the age groups or the race groups, removing variables according to new needs that we have for our products. All of these more broadly would be categorized as versioning, and I would like everyone to be able to do accurate versioning in response, for example, to the releases of new versions of the American Community Survey datasets or the other datasets of the Census Bureau, or new product releases according to new insights that you want to present. Corrections or errata, I would like for these tools to be able to help you, to aid you with producing informative corrections, informative errata to your products. And all of these can be achieved through conceptualizing automation into your own products, implementing automation by reusing code, reusing variables, reusing the census own products, own publications, in a way that generates the lowest maintenance possible for your products and for your, the new versions of your products. So here is the two tools that I'm going to be discussing today. Those are the ACS list and the ACS spec. I am going to be focusing on the ACS from now on. First, the ACS list. The ACS list is created starting from the original publications of the census on its web page. You are all probably familiar with this web page, which is the discovery tool. So what I do here to build the ACS list is simply to copy the full web page. You probably know that this is a slow and wieldy web page. I just copy it into a text editor. I do minimal curation work, and I copy all of the data, all of the list of variables into an Excel workbook. Then I take another product from the census website, which is the ACS table list workbook. If you're familiar with this workbook, it contains information about the universe from which every table is produced. And I join these two tables using, for example, in Excel, the VLOOKUP function. So what we end up with is this table that features each of the variables together with the universe where the variable comes from. And then we do a final task, a final step, which is taking the label column and separating it into different columns in Excel. You can use the text split function in Excel, which is a recently published function, or you can also use a text editor to separate the contents of the label column into separate columns. And then we put those columns back into the Excel workbook, and we set these column headers such as label 0, label 1, label 2, etc. So in summary, the ACS list is the comprehensive, complete list of variables in the American Community Survey, augmented with information about the, the universe for the variable, the table from which the variable comes from, and the labels corresponding to this estimate ready to use. And built in this form, the ACS list is ready for use in each of the products. Next, I'll describe how we create the ACS spec file. This is, once again, an Excel workbook. In order to create the spec file, we take the ACS list and we simply select those variables that we want to include in the product. We just copy those rows into a new blank workbook, and we add 1 or 2 or 3 columns where we define the groups and the labels for those estimates. So once again, the ACS spec is the selection of rows from the ACS list that go into a product. Now, I'd like to show you how, just very briefly, how we automate the work of selecting and downloading and integrating variables into a product, by using automation. So I am sure that every one of us who is learning to use the Census API will start with the approach of manually writing the URL to download data just in a text editor. You're probably familiar with, writing the whole HTTPS URL with the list of variables, and we would start with that tendency of just trying to maintain this URL by hand. So the idea here is that instead of trying to do all of this work by hand, we use programming code to build the URL. I'm going to provide you just a very simplified example using Power Query. For the platform, I use Power BI with Power Query. And in this case, instead of having to write the URL by hand and building it by hand on a text editor, we used functions such as table column and text combine to take the full column of variables that we have built into the spec file. And we add a few portions such as HTTPS and the API key to build the URL in an automated form. Then on Power Query, we fetch the data using that URL, and then we do the other operations that are related to the preparation of the data for visualization. As an example, we apply labels to the downloaded data. You probably remember that the data as downloaded from the Census servers comes with 1 column per ACS estimate. We do operations to transform this data set into the long form using, this is a reshape operation. And then we join this long format data set with the spec file itself. We join them by the same column variable name. And all of that has the purpose of creating this consolidated data set that comes with labels and comes with information about the universe from where the variable comes from. After we apply these labels, we can, for example, group data. In this case, we group data according to the age group, and we can proceed with the rest of the operations to build the product, which is, for example, combining the ACS dataset with datasets from other national sources. In addition to this work of downloading data and consolidating it into a product, the later tasks of, for example, changing and updating and upgrading the product can be achieved just by copying and pasting rows in Excel. We would create a new version of the ACS spec file by, for example, copying and pasting 1 or more rows from the list into the spec. In this one example, I am augmenting the product. Now, instead of only having 60 years and over as one age group, we can, for example, add an additional age group, which is 55 to 59 years old. So we add those two rows, and instead of having to repeat the whole work of downloading data, labeling it, grouping it, and consolidating it, now we can just repeat the code that we wrote in the first place with this new version of the ACS spec file. So once again, instead of having to maintain this URL by hand, we are now in a position that we write code that automatically manages the URL, downloads the data, and with, well, depending on the programming language that we're using, we can debug the code, for example, making the code produce the URL, and we can inspect the URL ourselves by just copying and pasting it into a browser. We can also, with this automation approach, combine this dataset, the SAS downloaded dataset, with other datasets to build the product, and also reuse this code in future versions of the product or in other products of the platform.
Got 2 minutes left, Fabio.
All right, thank you very much. So, so with this approach of building code that maintains our API query, we stop having to guess what is the variable that we are using, particularly when we try to communicate with the team. When there is people in the team who is not directly using the API, it's not going to be easy to provide them with an idea of what are the variables that are being involved and how is it that we're using them. But with the spec file that we can share, we are able to provide this information to the team in a way that it's a little bit more visual than just the URL. We are also automating the work of labeling, grouping, consolidating data sets. And in particular, we are able to reproduce or repeat that work after any change introduced, either by implementing a new version of the product or responding to a new release of the ACS. We can also replicate the code from product to product. We can use or we can reuse the code for management of data that has to do with states, or, for example, the ACS for counties, for places, for census tracts, or for areas denoted by the UCG ID. And finally, the work with the API can be audited, shared, and interpreted by your team in a way that is more meaningful and contextual than just the URL. Disadvantages include that this code, well, it needs to be custom built and maintained. It obviously depends on the language and the software that you use for your own platforms. Also, that errors in grouping or labeling can become too obscure, particularly because now you're maintaining the labels and the groups by hand on an Excel spreadsheet. It is a step above doing the URL management, but it can still be a little bit difficult to find problems on an Excel spreadsheet. And finally, manual intervention is still required to address differences between ACS versions. So your product still needs manual intervention when you need to upgrade it for a new version of the ACS. That's not observed with ACS variables because they are more or less stable, but geographic definitions are changing every year. So there's still manual intervention that is needed. So I hope that this has been helpful, and feel free to contact me. Here's my email if you have any questions or concerns how to apply the approach of spec files in your own work. Thank you very much.
Thank you, Fabio. That was great. Okay, next we have Ben Taft. And he's going to present a pipeline for tracking community-defined systems indicators using the ACS API and R. All right, you've got 15 minutes, and I will give you a 2-minute warning, okay? Great. You're muted, Ben.
I double-clicked the mute button. I was so excited to start too. thank you so much for coming to this talk. I'm really excited to be here. I'm really excited to have seen those last two talks, which I think are really related to what I'm going to talk about. And I'm also completely stoked about the fact that the API is going to be outputting CSV files, which should make some of what I'm about to talk about actually less relevant, but still useful. So let's get started. So I'm going to talk first about some of the context that motivated this work, which is basically saying, like, what is the community that I'm talking about when I say community? So my workplace higher expectations for Racine County is part of the Strive Together network of place-based partnerships. There's about 70 of us. We're across the country, and each of these partnerships is like a backbone service, backbone organization. We don't provide services directly. You could kind of call us like continuous improvement and project management and data consultancies for education and employment kind of nonprofits. And it's Strive Together's sort of core philosophy is motivated by continuous improvement. And it's founded in Cincinnati, highly influenced by the Cincinnati Children's Hospital's continuous improvement practices. And it's also strongly influenced by agile software development. So the Microsoft people love Strive Together, which is pretty cool funding-wise. And so the four pillars of sort of activity that they use, if you go to their website, are shared community vision, evidence-based decisions, collaborative action, and investment in sustainability. And I'm going to really be focusing on the first 3 points today. And so zooming in from Strive Together to, so when they say evidence-based decisions in Strive Together, there's really sort of two things that they're talking about. The first one is that they have these 7 key outcome areas that range from kindergarten readiness to family sustaining employment that are they call part of this cradle to career pipeline that if you can measure how well folks are doing in each of these things and make sure each of those are performing well, then the whole system's going to stay healthy. So the idea is just like in manufacturing, if you have a bunch of different quality analysis things during the production process, rather than just seeing if things are good at the end, you'll have more control over fixing stuff. And then those are outcome areas, but we all know that things like whether third graders are good at reading, those depend on the systems that those third graders are reading in. And so one of the other things that Strive Together works on, and what I'm really focused on in this talk, and I think probably a lot of people who work with ACS data are focused on, is systems indicators. So things like that help drive, that are measurable, that there's data about, that are helping to drive these outcome areas, but aren't necessarily directly in there. So again, third grade reading, housing stability, whether the kids has a place to sleep at night is going to definitely impact whether or not they learn how to read. So we can use census data to look at stuff like that. So that's sort of the base where I'm going with this. And so we're going to be trying to use the American Community Survey data to create these systems indicators that you can use to say, like, is this aspect of our community, which we know is going to be influencing one of our outcome areas, is it moving in the right direction? Because really what we want to be doing is changing the system and then having the outcomes improve because the system changes. So the folks that work in data in the Strive Together network are a really interesting group of people. I've been here working with them for about 4 years. My original background is in ecology and software development. So I'm coming in from a very nerdy end of that. And a lot of the people who are in the Strive Together data network are, like me, they're the only person in a fairly small team who's actually data specific. But a lot of them are folks who came in from like education or social science backgrounds and weren't afraid of Excel. And so they're really good at working with spreadsheets, they're really good at tables, but they have no experience with any kind of software development or data structure kind of jargon or best practices. And so they spend I've observed they spend a lot of time doing similar tasks. Like they'll spend a lot of time going to the data.census.gov, downloading a spreadsheet, manually moving things around or doing pivot tables, and then repeating that for the same process over and over again. And so the result of this is you get, I call it, because I want to be respecting that these people are working hard and doing a great job. These are artisanal, sort of artisanal data work, right? It's handcrafted, it's slow, but it's really connected to what the folks are doing. And so what I want to do is try to leverage their expertise as much as possible and amplify that with my understanding of coding. And so really we have sort of two different tasks that we can be working on. There's the non-coders can help us formally describe the question. They're really good at lurking in the ACS data, like we just saw with the lists and spec work. That's exactly the kind of stuff that you don't need to have any coding background to do to figure out which those which variables go to which table with which concepts. And then we have them create the same kind of I call them glossaries, but tables that describe queries, like we just saw. And then they can also help describe like the computations you'd have to do with these downloaded data tables in order to get the systems indicator that that we want. And then as a more coding oriented person, my or someone else's job in this is to help get that question into as a framework that can be turned algorithmic, and then use some of these coding tools that we've developed to make that process more efficient. And so the end product we're going to get is two things that are generalizable. One, which is like a table that captures the subject matter of the query, like school-age children was going to be specific rows from a few specific ACS tables, right? And then some scripts. So just like what we just saw, and forgive me, I'm a typical nerd. I forget names unless I've seen a bunch of times. So the gentleman who just talked, he had that amazing slide with the Power Query steps that shows what you want to do. And that's the kind of thing that a coder can present, right? But that's reusable. So let's move forward with a couple more specific things. So I'm going to shamelessly plug the R package that I wrote, which is kind of in direct competition with Tidy Census, because I found that a lot of aspects of Tidy Census were really smart, but not quite what I was looking for, and so I rolled my own. So this R package is called HERC ACS Tables. HERC is for Higher Expectations for Racine County, ACS because it's ACS, and tables because we want to be using tables. And there's really two core functionalities that it provides. One is that it has sort of a unified single function for pulling data from any census API, actually not just the American Community Survey, and that's this fetch data function, which is shown here in very small print, which you probably can't see. I'm not going to go into a huge amount of detail for it, but basically you feed it the variables you're interested in, and then separately parameterized are the geographies that you're interested in, and then it will pull the data and give it to you in a tidy format where you have, just like in Tidy Census, you have geography, variable, and then the quantity. And then you can join that to a glossary table, which I'm going to talk about in a second. The other thing that I have, which I hope you'll think is cool, is a series of functions. So just like we said before, I think someone mentioned in chat that Tidy Census downloads the whole discovery document into our tables. Yes, so this HERC ACS tables already has built into it all of the discovery documents formatted into R tables. And what you can do is you can use some functions to actually create, and we're seeing an example of this right here, a table that says, okay, here's the what row, what the full variable is, and then it splits up. In this case, this is some health insurance by age information. It splits up that label, so you don't even have to do the separate function. It's already built in there for you. You just say, what do you want the names to be of the different parts? And then you can take a look at it. So that's what I'm talking about, is like you can give people you're working with some examples of what tables look like, and then work with them a little bit more closely. So the key things here, the artifacts that I want people to be thinking about producing, are two different kinds of tables that are used to parameterize your API queries that I'm going to call glossaries, because I don't think that jargon word has been used a lot in other things. So I'm not competing with folks, and it really does gloss. It's like saying, okay, here's this compact thing that holds a geographic location or a complicated set of things that the ACS packs in, and then it glosses all the different meanings that it goes with. So for a systems indicator, you'd have a table which each row is like each row is going to be a variable, and it'll tell you what that count of people or dollar number pertains to, all the different demographic information that goes with it. And then there's also going to be a post, and then that will always be run with the fetch function. Everything will just always be fed to that fetch function, and then the output will have a predictable format. And so then you can have a single post processing, which I usually call wrangling, script that will take that those rows from the census table and turn them into the actual tidy data that you wanted to use to make your analysis. And so the parameters in that systems indicator glossary are going to be what survey what data product comes from, what specific variables in that data product, and then the meanings of those things. And then
You've got 4 minutes left.
Okay. And so then the partnership is you can define your location as well. So I will blitz really quickly through how that looks like an example. So here's a systems indicator glossary. Got the data set. This is ACS5 or ACS1, the group, the index, and then get collapsed into variable. And then this is about plumbing and renting houses. And so you have 2 columns that tell you what that is. And so then you can, so then there's some R code that would create something like this. Similarly, you can build a table of geographic footprints and then use that to repeatedly fetch the same data for different geographies. So here's what the pipeline then would look like. So there's a systems question, and then you as a programmer help people explore the ACS, create a glossary for variables, create a glossary for geographies. Those get fed in the query, and then the results of that query get fed to summary scripts. I don't have like a report template or anything on this, but that's going to vary by person who uses it. And then that's going to give you a report on local systems indicator. And then all you have to do is swap out a different glossary for geographies, and you can rerun it for anywhere in the country. So that's sort of the idea of the pipeline. And then I have talked too long, so I can't really go too much into this example. But the main idea I want you to get is that as a programmer, you can say, okay, here's the categories that are in the ACS. And then, so like, for example, when I was talking about insurance, I was like, okay, here's City of Racine, here's all the different ways the ACS keeps track of insurance. And like, oh my gosh, that's too much. Let's just look about private versus no private insurance. And I was like, okay, we can do that. And so then we came up with this final glossary. And so there's only, so we have all the ages and the insurance types, and then we break that down into public versus private. So we can do our final aggregation, and that's the R code that does that. So it actually ends up being, and so like that's available on GitHub, right? So then you say, okay, here's the table, here's the post download wrangling script. There's a little package, a little unit that you can use to compute the systems indicator, and it's the community that you talked with that helped you build that table, so that there's already buy-in, and they can help you reproduce it when the census changes its variable coding. And so and then people don't have to be as scared of the coding. So like, here's an example of health insurance, the results you can get, health insurance coverage by age, the fraction of people in different age groups at the US, the Wisconsin, Racine. You can see, you've got things set up so they're all in the same sort of format, and you can look at the time frame, and you'd be like, oh, look, the US and Wisconsin are pretty similar, but kids in Racine are much less well insured. We've got to fix that. So there's actionable stuff that you could do. So I blew through that really quickly, but I hope you like it. And so there's the schematic, and there's my email address. Note that they hilariously reversed career and cradle in order to get the domain name. So my email address is career2cradle, and the slides will be available. So the HERC ACS table is on GitHub, and there's also pretty extensive documentation And if you haven't heard of Strive Together, check us out too. We're pretty awesome. And Hubble. Thank you for your time.
Thank you, Ben. Make sure you go check in the chat, maybe upload some resources in there for people, because I think people are interested in any links you can provide. Okay, so our last presenter we have now is Jan Vink, and he's going to talk about a flexible Excel tool to retrieve ACS data. All right, you got 15 minutes, Jan, and I'll give you a 5-minute warning and then maybe a 2-minute warning if you're getting close.
Thanks. My name is Jan Vink. I work at Cornell University in the program of Applied Demographics. The program of Applied Demographics is within the Cornell Brooks School on Public Policy. In the program of Applied Demographics, we focus a lot on census data and focus on New York State. We are part of FSCPE and the ACS, the SDC networks. Just a case study throughout my presentation, question the share of children aged 10 to 14 enrolled in private school. This information is in table B14003, and the table looks like this. It's not easy. Not easy. You have to combine some numbers and etc. to get to the share that I wanted to calculate. So, and even if you download it, I had the privilege of going last. So, and I kind of showed this already that this is not intuitive within the workflow. And there's far too much data in the data table. Of course, you can limit it to data.census.gov, but it's not easy, and especially if you want to repeat that multiple times. Data.census.gov can be very cumbersome, as we all know. So, yeah, the Census Bureau API is an excellent solution to get just that information that you want. So in this example, the variables get me the variables I need. Soon we are all pretty familiar with what an API looks like, but yeah, it's a domain. The path kind of defines the year and the product you want to get your data from. Then the query, combination of keys and values, the get parameter, the list of variables you want, and then there are a couple of geography parameters. Now, finding the variable names, Fabio and Ben already talked about this. Yeah, there's several places where you can find those variables and download them from the column metadata, because I could easily filter just those variable names I was interested in. We probably have all seen something like this before. If you create an API, fill it in the web browser, then this is the result. It's nice. It's a little bit of a pain to get it in Excel with the square brackets and all the quotes, and not straightforward. This morning was already mentioned, the game changer of the output format is CSV. It's really a game changer. As you add that to your API call, then your web browser automatically generates a CSV file, and you can open in Excel, and it looks like your picture beneath. You can now even skip the step of starting in your web browser. In Excel, there's a data option in the menu from web, where you can give that, paste that URL, add that output format as CSV, and if you click OK, then Excel comes up with this table, kind of from, does it look good? This is from Power Query. Yeah. In most of the cases it will look good, so you set load, and you have the data in Excel, in an Excel table, which is a slightly different concept in Excel than a range, with all the variables in there that you requested. Yeah, as I mentioned, Power Query is running behind the scenes. Power Query is an excellent tool to clean your data, filter, and all those kind of things. Out of scope for this presentation. This is nice, but as previous presenters also already mentioned, that you have this result, but no information how you got it. So if you open that Excel sheet a year later, you don't have that information from what year is this data for? How did I do this again? Yeah, I think that is important to keep in mind. A lot of times you need more than one API call. If you want data from different data products, from detailed tables and from a data profile, or you want it from different years. Set of geography definition is also kind of limited. So, for example, you cannot ask for the state and all counties in a state in one API call. So you have to have 2 API calls. So there's often a need for combining data from different API calls. Excel macros can overcome some of those limitations. You can make use of the Power Query capabilities from macros, and macros can easily loop through different instructions and generate those API calls and do some data manipulation. So that was the idea for me behind the development of this Excel macro-enabled workbook. My ultimate goal was to create a table with a select number of variables or derived variables, or system indicators as Ben called them, for a set of geographies from one or more Census Bureau data tables. To start that Excel workbook, there are 2 worksheets, one that defines the rows, the geographies, and one defines the columns, the variables or system indicators for each column. So this is what geographies look like. One base URL from what source do I use to generate those variables. And of course, if you use a different year or a 1-year ACS or the Sentinel census, that list can be slightly different, also depending on the geography level. I gave each request an ID, so the state, the certain tier, that is a region here in New York, with a list of counties, the sub-counties in Albany County, Ithaca City School District, just a selection of geographies as an example. The variable definitions in my worksheet look like this. On the left, the ID for each column, a short description, then the year, survey, and product, from where do I want to retrieve my data from. List of variables, and previous speakers mentioned that a couple of times already, how to get to that. And then, because each variable is one column, one value, but can be based on multiple values, I define how my system indicator is calculated. and I do that in the Power Query syntax. The last column defines if I also want to have a regional total. So if you click that, then not only the individual geographies will get a value in that column, but also the combined geographies. For some variables like median household income, that of course doesn't make any sense. There's a big button for retrieve data, and then a few minutes later, you have an Excel sheet that looks like this. So the request IDs on the left, all the individual geographies, the ID and the name, and then the columns are all the variables I defined. With a little bit of formatting, it looks like this. And I was pretty happy with this kind of result. It's a little bit of a dumb macro. So I said the share household income greater or equal than 100,000 to have a total for the certain tier, but I retrieve the data from the 1 year ACS. So not all counties have 1 year data, but the macro is still adding it together. Be careful using that option. If I share the private 10 to 14 in 23 in 2013 for different counties for all the geographies I defined. Besides that summary file, I also get results from each of those queries. Each of the variables downloaded and the calculated system indicator at the end. Another example, building a time series from 5 year ACS. Same variables, same calculation. And a few minutes later, I had the information to get lines for the total certain tier, Ithaca City School District, and a list of comparable school districts in the area, and a line over time. Some resources. The Census Bureau has a lot of resources online, and I created a website on our pages that goes to these steps as well, and they also can download that Excel file. Thanks.
Thank you, Jan, for that. And you ended 2 minutes early. Nice job. Okay, so the chat has been just popping the entire time. Additionally, we've had questions come in through the Q&A, and they have been essentially answered throughout the entire session by the presenters. So please take a look at those. If you have more questions that you'd like to ask, now is the time. Please put them into the Q&A. While we wait to see if anyone has any more questions, I just want to say thank you to the presenters. This content is really interesting. I consider most of the people that are presenting certainly power users of this data, and I love the demonstration of different tools and different approaches and different ways that we need to provide the data, because a lot of times we can all do something in one program, but ultimately often Excel is a universal language across disciplines and across users. So I do appreciate seeing some of these processes also done in Excel. Ben, I really enjoyed looking at your new package. I'm definitely going to check that out. like you saw in the chat, you know, I've been using Tidy Census for a while now. I have Kyle Walker's book, you know, all of that. So I'm excited to check out kind of this new tool. Really appreciate that. Anna, I actually thought your presentation being first was great. It kind of set the scene also for just really how like ACS data is formatted, how it's presented, and kind of different alternatives and ways that we can work with the data. So actually, thanks. That was great. Fabio, again, that was a really great presentation too. There was a lot of power querying going on in these, and I really, really loved that as well. Let me check the Q&A again. I don't see any new questions. So if everyone is done asking questions, then we can have a little bit of our time back to have a little break before the next session starts. Maybe get like a little walk-in or something. So again, thank you everyone for attending and being very interactive in the chats and the Q&A. All of the recordings and slides and everything will be available after the fact. So yeah, everyone go get like some fresh air and sunshine or something. And we'll see everyone back in the next sessions, okay? Thank you so much.
Thank you all.